Hello, internets.
Hello, internets.
Yeah. So, nice. You got like you got a whole Dragon Ball Z pose going on there, Satch. Do you
The
remember
Ginyu Force.
oh my gosh, you remembered the name. That's awesome. The Ginyu Force. Now I just need to see you transform into your final form.
Yeah, right. Rich, we can do it next time.
Well, I'd be at the top, so I'd be like this. Not this guy.
Nice.
I remember.
Yeah, that's right. This is the correct pose. This is so
I
good.
just know we have lots of angles going on.
I want to be the time guy. This is in the middle. Oh no, he's in the middle. It goes there. Okay.
So unfortunately, I forgot to download the black hole thing to get audio from you to go through my stream. So instead, I'm just picking up the audio using this mic from my desktop. So I forgot to do that. I forgot to set that up before the stream started. So sorry, you YouTube people. You're going to have to put up with slightly worse sound than usual. But I mean, in the grand scheme of things, like if you think about it, when we've done this in the past, I would sometimes forget to record you entirely. So this is better than that, right?
That's true. It's not the worst mistake possible.
It's not the worst. In fact, this is more reliable because I can see your audio levels going through my mic in many ways.
Perfect.
Yeah, also having having a new computer here means that things may not behave exactly the way that we expect them to. But let's try having you folks join a live session. We haven't done that in a while. All right, I got the link. I'm pasting it in the Discord. Paste.
Yes, Discord.
Discord. So let's. I've also I didn't bother reinstalling Quokka. I think we can do without Quokka. Are you folks using Quokka on your local machines?
No.
I see. Do you just run the programs from the terminal?
Yeah.
Okay.
Worked. I
So
think that probably worked better for this one because I wanted to see the instances of when things are added to the arrays.
okay. Okay. So I guess today we're gonna focus on the problems because I didn't have any other lesson things to teach you anymore. So
Yes.
okay.
This is the math.
So we can work on problems. The other thing that I wanted to do was maybe do like a review. Did you want to maybe do a review of everything we've learned?
Yeah.
It's fun.
Yeah.
Okay, let me get a review up. I have files on my desktop that should do the trick. Let's pull up a new tab over here. Pull that up. Okay. So let's go back to our main. This is where we started doing all the things. Let's quickly. Why not? You know what might be very nice? We go through this, and you tell me what things do. Okay.
No, this is gonna be hard, but.
Oh, but that's okay. I will help you. So first off, I'll start us off with the hard stuff. This is essentially an import statement. It brings in some code from a library called file system, and then it allows us to read a file from the hard drive. In this case here, we're reading a dictionary.csv, which if you were to take a look at it, it's all the words in the dictionary, one after the next. And once it reads it in, it splits it on new lines so that ultimately this words is an array of strings where each element in the array is one word. Yeah? Okay, so let's go. What does line 12 do?
I know what it does.
Go. Tell me.
It prints out the word. Oh my god, it says it right there. In the terminal.
Yes, that's right. Oh, someone's throwing some energy around. Are you
Circles.
Positive vibes.
It's part of the force, continuous force again.
Yeah. Okay, what do these slashes do here?
It turns it into a comment and not a code anymore.
Yes, correct. Okay. Tell me, what is a Boolean?
A true or false statement.
A true or false value. Yes.
Value.
Okay.
Value.
Yep. What happens if you what does line 33 do?
It prints out true value. A true value? Does it print out if whatever you put in that area, if it's true or false?
Correct. So so in this case here, specifically line 33, what will it print out if I were to run this code?
A true value, like how it's written there?
Nope.
Like when you... I'm not sure.
So a true value is defined on line 30.
Oh, true. It prints out true.
Correct. What does line 34 do?
Prints out false.
Yep. Okay.
I see, because already defined above it.
Yeah. What would happen if you tried to do something like this?
Since that's not defined, then it would just write out what you wrote out in red?
Nope. Let's create a new file here just to, since this is kind of like your exam, exam.js.
Oh, I'm going to my exam!
All right, so here we have a non-existent value. So if you run exam.js, you get an error, reference error. A non-existent value is not defined. So this is an error. You can't do this.
Oh, that's tricksy.
Is it?
That's tricksy.
Okay. Well, I mean, it's important.
Okay.
It's important for you to know. It's important that you understand that if you define a variable and don't give it a value, let me rephrase. If you don't define a variable, then you can't use it. You have to define it somewhere. You either using const or let or var. Okay. What's this?
Meaning of life. A const. Well, is it just a number that you decided that meaning of life equals 42?
Yes. Yes, that is exactly right. The way to say it is so when I ask you, the answer I'm looking for is line 39 creates a variable called meaning of life and sets it to 42. Sorry, that's not correct. Line 39 creates a constant called meaning of life and sets it equal to 42. Yeah?
Okay.
That's what you said, by the way. Totally correct answer. I'm just explaining
right, but
what
that's the wording.
That's the wording I'm looking for. Yeah. Line 40.
It creates a constant called pi equal to 6.28. That's not pi.
Yep, this would lead to a bug somewhere if someone were to assume that pi is equal to 3.14 and it turns out to be 6.28. I'm pretty sure we did that together. How about line 43?
43. So creates a constant double quoted. It's a string.
Yes.
Shad's dog.
Mm-hmm.
In double quotes.
Yes. What does line 47 do?
47. Back prints out the meaning of life is meaning of life on line 45. It prints out this part of it.
Yes, and what will that be when it prints it?
What is this part?
That is the interesting bit. What does that do? Do you remember?
What does a dollar sign do?
Ah,
It's, yeah, well, what it does, see how there's a constant meaning of life up there? It's 42. But I think in a string, it needs to be formatted a particular way in order for you to pull that constant into it.
So,
Meaning of life is to
Oh.
those characters to
Right.
allow you to input something into the string.
yes, that's correct. Does that make sense? So we call this string interpolation, and what it's doing is it's grabbing another variable, meaning of life, and puts it here. So it will print meaning of life is,
The meaning of life, which is 42.
yes.
So would it then print 42 because it's defined above?
Yes. So let's try it out. So we can go to exam, paste this stuff here. Well, you also need meaning of life. So you need 3 bits of code in order for this to work. You need these 3 bits of code. You need meaning of life equal to 42. You need backtick quoted, and you need console log. And if you run this now, you get meaning of life is 42. Yeah?
Yes.
Nice. Okay. We talked a little bit about missing values, but it's been 3 weeks since I told you what the difference was. If I happen to even... You think you can remember? Do you know the difference?
Well, yes. A null value is a value that is null. It's a value that it doesn't have a value, I guess. Well, it's null. And an undefined value is something you cannot define. So even if we both don't have... Okay, I know I'm describing things with the same words. An undefined value is something that you haven't given a value to.
Okay.
But a null value has the value of null.
Hey, that's great. Good job. Okay.
Yes.
All right, how about the variables? What's the difference between these 3?
Oh. Oh yeah, I remember that you said variables are like lets, but variable is more old-fashioned. People don't usually use that. I mean, var.
Yeah, I don't care. It's okay if you don't know the difference between var and let. I couldn't even tell you right now what the real difference is. So don't expect to be able to. I didn't explain it to you before. You shouldn't need to know. But what about line 56? What's the difference between a const and a let?
I mean, we keep using it. So let is when you're like setting your own values. And then const is something that I don't know, I feel like I'm describing it.
Yeah, no problem. It's okay.
You got it.
So a constant can't be changed after you've assigned it. So if you say const something is equal to something, you can't ever make this value equal something else later. Okay, but you can do that with a let. If you say let new style variable equals this, you can later on say new style variable equals something else.
Okay.
Yeah, but if you did if I were to write some code here, a constant equals 3, this would be an error. Let me show you to prove it. We'll put it in an exam. There we go. So here we set const equal to this, and now we try to change it. If we run it, we get an error. Type error, assignment to constant variable. Yeah? Make sense? Whereas you can do that with a let. If we put new style variable, so this is a let, and run it, no problem. The program runs. Nope. It didn't. We had no console logs, so it didn't print anything out. But it just works. Yeah. All right. Moving on.
Okay.
Let's remove this. Moving on. Okay. What does line 61 do?
It's an array.
Okay.
Oh, but it gives you definitions for what a fruit is, or what fruits are.
So again, the explanation I'm looking for sounds like this. It creates a constant called fruits and sets it equal to the list apple and banana. Yeah?
Okay.
What does line 63 do?
It prints out fruits as defined as apples, as defined as this list.
Okay.
What does the number 1 do though? It's in these square brackets. Does it just print the first one?
Yeah, well, close. It prints the second one because in JavaScript and many languages, 0 is the first one.
The elusive 0.
So if we run this, we get banana. Yeah? So the square brackets is how we access elements in a list or elements in a dictionary. In JavaScript we call them objects. So it lets you access elements in a list or elements in an object, right? What does line 64 do?
Does it... You want to go?
Yeah, I know.
Go ahead.
What it does is it pushes it to the end of the array.
Yes.
So like it put it right here.
So it added to the list?
Yes. So after this line, fruits will contain apple, banana, and orange. What does line 68 do? You can go, Rickles. I don't mind. I've been focusing on Satch. I didn't mean to focus entirely on Satch the whole time.
I believe what it does is it looks to see if grape is included in the array.
Correct. It checks to see if grape is inside the array called fruits. And since it is not, what will it do?
It will say false.
Correct. So let's show the jazz. Put it in the exam. Let's remove the other console logs and run. Prints false. Yeah. Okay. Next, objects. We did some objects a little. We did a little bit of objects. Objects is like an associative array. It associates a key with a value. So, for example, it associates my name with my phone number, and Satch's name with her phone number, right? So this is the. Do you want to? I'm gonna say it. This defines a constant called phone book and assigns it to the literal object that defines mine and Satch's phone numbers. Associates my name and Satch's name with our associated phone numbers. What does line 76 do?
It adds Richard's number into the objects, into the phone book.
Both of those statements were correct, and just the way that a computer scientist would say it. Well, someone who was doing JavaScript anyway. How about line 77?
It deletes Shad's number in the phone book.
Yep. What would happen if I did line 79 after running all these lines? What would this line print?
It would print out Satch's number and Richard's number.
That is correct. Let's take a look at it so that we can be sure of all these things. Run. Yep. Cool. Nice. Okay. I want to move a little faster, so we're just gonna do some of these quickly. What does line 86 do?
Multiplies 3 times 4 and prints it out in the terminal.
Yep. Sounds good. Do you remember the difference? Oh, yeah, these were things that we did early on, but we didn't really use until later when we were starting to write code together. What does line 94 do?
Oh, the double and.
Mm-hmm.
I'm forgetting it.
All right.
Is that not?
That's the exclamation point.
Right.
Mm-hmm. And is and. and is the logical operator of and. And what about these pipes? It's not the logical operator pipe. Only and is the logical operator and. What about the pipes?
I don't remember these pipes.
Is that also like, sorry, is it the not include?
No. So and is the two ampersands. Pipes are the or operator. Do you remember or? Do you folks remember what and means and what or means and what not means? Nope.
Is it how we think it, like logically speaking?
Yes. Mm-hmm.
So and means something in addition, and
Yes.
not means excluding something, and then the pipes or means one or the other.
Correct. Well, sort of correct. So let's recap real fast. You might say, I went to bed and I slept. That means both of those things are true. And if either of them are false or neither of them are false, then that means the whole statement is false, right? So if you said I went to bed and I slept, but then you didn't sleep, then that means the whole statement is not true. If you went to sleep but didn't go to bed, still the statement is false, right? And of course, if you didn't go to sleep or go to bed, then the whole statement is false. And the statement is only true if you actually went to bed and you went to sleep, right? That's the usage of the word of and, yeah? Or is a little tricky because we often use the word or in common parlance, in common speakage, that not entirely correctly. Not the way that, sorry, that's not true. Not the way that the computer understands or. So if I say soup or salad, usually what that means is soup or salad but not both, right? But in computer speak, soup or salad is you can have soup or you can have salad or you can have both. And all three of those states are true. Right? So if I asked you, did you have soup or salad? And you had soup, you could say yes. Or you had salad, then you could say yes. And if you had soup and salad, then with this version of the logic, then you can also say yes. I had soup or salad, right? Because you had both, right? But if you didn't have soup or if you just had a sandwich, then that means the statement's false because you didn't have soup or salad. Make sense?
It's a good analogy.
Yeah.
But it's important to remember that in computers, like that there is that distinction. Soup or salad is not in computer parlance. We would call that exclusive or, but you don't need to know that. You don't need to worry about exclusive or. Just and or. That's how you understand them. And the way that we look at it is we say, false or false is false, but false or true is true. True or false is true. True or true is true. Okay? Whereas with the AND operator, the only time the expression is true is when the left is true and the right is true. And last but not least, not is the opposite. So if you say, if I asked you, did you eat a sandwich? Or sorry, if I say, did you not eat a sandwich, right? And you ate a sandwich, the statement's false, right? But if you ate soup, that means you didn't eat a sandwich, the statement is true. Make sense? Okay. So this is key, by the way. Most of programming is going to be around various expressions like this, right? When you are checking, we can go back. Well, I'll show you that we actually use this in a few places already. Okay. I think we're making good time. Let's keep going, yeah? So ooh, I'm getting hungry. Kind of wish I had a snack. A snack would be good.
A soup, a salad, or a sandwich?
That's going to happen. All right. So if you recall, there's the 3 equals and the 2 equals. Do you remember what the difference is?
Yeah. I know what 1 equals is.
What is 1 equal?
1 equal is assigning a value to a thing.
Yes.
I forgot what 2 and 3 was. Last time you explained it to me, though.
So the only thing you need to remember, hey mom, the only thing you need to remember is to use 3 equals. You just don't ever bother with 2 equals. The difference is it's kind of what's the word? Academic, really. 2 equals this. If you had 2 equals, this statement would be true. Line 98. With 3 equals, the statement is not true. Does that hint give you an idea what the difference is between 3 equals and 2 equals?
So for 3 equals, it's looking for the same value as well as the same contents. Does that make sense?
You mean type, and yes.
Type, yeah.
Because the type of this one here is a number, and the type of this one here is a string. JavaScript, for reasons unbeknownst to history, actually that's not true. I'm sure people know the reason. For whatever reason, back in the day, JavaScript decided that it was okay to check equality with 2 equals. Most programming languages just do not do that. 2 equals means strict equality. They are both strings and their values are the same, or they are both numbers and their values are the same. With 2 equals in JavaScript, this would be true, meaning to say the number 3 is equal to the string 3. Yeah? Okay, what does line 100 do?
It adds 2 strings.
Which would print out
6 in this case.
Nope.
Because 3 is equal to the string of 3, isn't it? Wait, you just said. Help me.
So.
Oh, it'd be 3, 3.
Yeah. Because they are. I think Niwako's here to say hi.
Hey, Niwako! Yay.
Do they see me?
Yeah, they see you and they can hear you.
Hello. Hi, Niwako.
We're seeing you on the television right now.
I think Niwako must have been watching the stream because she brought me a snack. Thanks, Niwako.
Yeah.
Hey.
Her spidey sense was tingling.
Life's good. Okay.
What are those things?
Almonds and cashews.
Nice. That's a good combo.
Yeah, they're refrigerated, so they're nice and cold.
Oh, refreshing.
Okay, so where were we? Yeah.
A string of 3 plus 3.
So when you add strings together, it's concatenation. It joins them.
What's the word? Concatenation?
Yes.
Concatenation is the word?
Yeah.
I have never heard of that word before.
Link things together in a chain of sequence.
Concatenation.
What does line 102 do?
It prints out which number is bigger. Wait, what does it do? I don't know.
Think of a value. Not like in the sense of the previous things.
It says 3 is greater than 4, doesn't it? Or is that not what this is saying?
That is what it's saying.
So what does it print out?
3 is greater than 4?
So greater than is an operator. It evaluates that to an expression.
So it print out false?
Correct. Yeah, we've been spending a lot of time in logical. So a lot of things we're looking at here is just printing out true and false. Different kinds of trues and false. Well, I lied. This is not. All right. So we did this too. We did some if statements. So if you recall, we set pi to 6.28. Yeah.
Yeah. Right.
So and 6 is 6. So what does lines 107 through 111 do?
So okay, hold on. So the first statement is false. If 6 is greater than 5, which it's not, then it would print out that the universe is broken.
Correct.
Okay.
Okay. Then we did some stuff with random, if you recall. Generated we wrote some code for the magic 8-ball. And then we printed a Christmas tree.
Classic tree.
Classic. I don't know what all this other stuff is. I think we
We're trying to automate a Christmas tree.
Yeah, I see. Okay. None of this matters. Let me see. So I think we got to so there's a Christmas tree, and then we have fruits again. I don't know why. I don't know what all this code is. But anyway.
I think we were doing one of the problems. I think we were doing the one. You're teaching us a part about how to do the left hand.
We did that problem together.
Exclude certain letters or include certain letters.
We also did arrow. I thought we did arrow functions, but it's not here. Where did it go? We just printed some stuff. Interesting. Okay, but if you recall, we also did loops. Oh yeah, we were doing loops. I showed you loops, for loops. Yeah.
Oh yeah.
Hey Mitt.
I meant.
None of this matters, and nothing else matters. Yeah. Okay, where are we? So you remember for loops? What does this for loop do? And let's talk about.
Embedded loops. Let's go.
Yes, you did idea for the loops for our problem.
I did have a good idea, but it doesn't mean I can define what they are.
No, try. Go ahead, Satch. Try.
Okay. So let stars equals a string. This is a string.
Now, what is that string?
Nothing is in there.
Correct. It's the empty string. So we define a string called which is the empty string, and make it equal to stars. Continue.
Okay. For let Okay, so this is the for loop.
Mm-hmm.
Let I equal 0.
What does that mean?
You know, whenever I see the i's and the pluses, I don't understand it.
Okay.
So I don't really know.
Try. I think you do.
Did you just? Okay. Did you put I in as like what? Is it a variable you made up, or what does I mean? Do you know what I mean? Why do we keep using the I variable? And is it a variable?
Okay, the question is, internets, why do we use the letter I? That is a good question. I believe it is short for index. And every programming language book I've ever read uses I as the iteration variable. Oh, that might be what it is. Iteration is the iteration variable in a loop. But it doesn't have to be I. It could be your name. It could be Sachi. Let Sachi equal 0. It could be anything. It's just...
And the funny thing is, afterwards, for other loops, they then follow the alphabetical order.
After
I, J, K.
It's true. It is true.
God. That's why you had a J in the other one. I didn't know what that was about. Okay.
But I haven't passed K. I never passed K.
You haven't had to have too many for loops.
I haven't had the quadruple loop. So, lucky for me.
See, that was my suggestion earlier. I said, why don't you make 2 for loops? And that's why you use the J. There you go. Okay. So I equals 0. And then I is less than 4, which is true. And I equals I, which is 0 plus 1, which is 1. And then stars equals stars, which is empty, plus, now it has a string with the star.
What is this called? We just learned it. What is this called?
You just...
Remember, we did it back here when we said 3 plus 3?
Oh, it pulls it into a string together, so then it's stars, star, together. Is it?
What's the word that we used? Remember? Concatenate?
Concatenate.
Concatenate. So we concatenate stars, the previous value of stars, with a star, with an actual star. Okay,
No.
let me explain to you how I want to hear it explained to me, right? So we create a variable called stars, and it's set initially to the empty string. Yeah?
Yes.
With me so far? Then we have a for loop, and in the for loop, there are always, well, in JavaScript and languages like JavaScript, there's always 3 pieces to it, okay? The first piece is the initialization, right? The second piece, and they're separated by semicolons, okay? And the second piece is a conditional check. As long as that check is true, you continue to do the loop, okay? And then the last piece is what to do on each update of the loop, okay? So this happens only once. It's the initial check. This piece here, the second piece, is a conditional check. It needs to evaluate to true or false. The moment that it's false, loop doesn't run anymore. The last bit here, you look like you want to say something, Satch. Go ahead and say something if you want to.
Oh no, it's just coming together now for me.
Okay. So ultimately then, what is this thing? What is, in English, what is this now doing?
Okay, so it's evaluating if it's telling you to add 1 every time you encounter I at the last part, and if it doesn't, I don't really know about the stars part of it now.
So this part here is taking the previous value of stars. So initially stars is empty, right? So this is empty. And it's adding, and by adding, it's concatenating. When you add two strings, we no longer call it add. You concatenate the strings, right? So what is the value of stars after the first time this runs?
So it's... Okay, it's stars with a star next to it. Is it the first time?
So,
with an asterisk?
So initially, stars is empty. Empty means nothing. It's no string, yeah? And then we add empty to one star.
Oh, so there's no stars written. It's just going to print, it's just going to have an asterisk. And then add one asterisk every time these rules fall in line.
Yes. So then finally, what happens at line 145? What will it print?
It'll print an asterisk. Hold on. First is empty. It'll print one asterisk. Is it? Or would it print out a tree like this?
So let's go through. Let's walk through it again. Yeah. So first, it sets the stars to be empty. Then you initialize the I to be 0. And as long as I is less than 4, you're going to run this loop. And then, each time you go to the top of the loop, you'll increment I. So the first thing you do in the first iteration of this loop is set stars equal to stars plus star. So what is it after the first iteration? What is stars equal to?
It's 0 plus an asterisk.
Empty plus an asterisk. Okay.
Empty. Yeah.
Which is equal to... What is empty plus an asterisk?
Isn't it just an asterisk?
Yes. Then we go back to the top and we increment I. I is now equal to 1. And then we check, is 1 less than 4? The answer is yes. So then we do this again. What is stars now equal to? What is...
1?
You mean asterisk. Stars is equal to asterisk.
Yes, the asterisk.
What's asterisk plus asterisk?
Asterisk, asterisk.
And then we set that equal to stars. So now stars is equal to 2 asterisks. Yeah?
Yes.
So we go back to the top. I is still 1. We increment I. I is now 2.
2.
And we check. Is 2 less than 4?
Yes.
So then we do this. What was stars before?
2 now.
And then what does this do?
3 asterisks in a row.
Correct. So now we go back to the top, and then what does this do?
It adds another, so now it's 3.
I is 3.
I is 3 now. And 3 is less than 4.
Yes.
And then stars is equal to 3 plus another asterisk, which is 4 asterisks.
Okay. And then?
And then finally, was it 4 before?
Nope, it was 3. I is 3.
I is 3 plus 1 is 4. And 4 is equal to 4 is not less than 4.
Correct.
So then it would stop.
And then?
Print out the asterisks.
How many?
1. Would it be in one line? In a row. So 1 star, then 2 stars, then 3 stars, and then 4 stars?
No, it would be just 4 stars because we only print once. But that's a good question. All right, let's try it out. Yeah. So let's run it. So it just.
I was influenced by the Christmas tree.
Yeah, you shouldn't. Just focus on the code. Okay. So you thought that it might print 1 star, then 2 stars, then 3 stars, then 4 stars. How would you make it do that?
Well,
Mm-hmm.
I do not know.
Oh, well, it's a really simple idea. Console.log stars. If you do this,
because now it's inside of it, so then it would go all the way to 4.
let's give it a try. Let's run that. Well, see? So you may want to yeah, it's lopsided. To get a tree that's nicely indented would require even more work, because you'd have to calculate how many spaces to put based on the number of stars that you have and based on the size of the number of stars you're making. So that requires a bit more math. So it's a lopsided tree. But with time, you'd be able to do it. But when I was giving you the homework last time, I hadn't taught you for loops yet, so I didn't expect you to do this. You went and tried to do it anyway, but... Okay, then we have the while loop. This while loop is kind of similar. I was trying to show you how you can write a while loop to behave just like a for loop, where you start by creating an empty string. Yeah? And then you initialize I. And then this is the conditional. You're checking to see when I is less than a certain value. And so long as that's true, you will concatenate star to stars. You'll concatenate an asterisk to the variable called stars2. And you'll increment I. And you'll keep doing this until I is no longer less than 5. So when the expression I less than 5 is no longer true, you stop and you'll print the stars out. Yeah?
So are these rules less stringent than these rules because of the while?
No.
Or is it the same?
It's the same. It's a choice what kind of loop you make. So for loops are common when you need to iterate over an index or when you need an iteration variable. But while loops are useful when you don't need an iteration variable. Like when you just want to loop until a condition is no longer true. Like you just want to loop forever, basically. So that happens frequently in programming. And here is an example of using a while loop without an iteration variable, right? Basically, rather than have an iteration variable to count up, we instead just say as long as the length of my stars variable is not 8, add some asterisks onto stars until we have stars equal to 8, right? So this is going to print out 8 asterisks because it's going to keep adding asterisks on until you have 8 of them. Make sense?
Yeah.
Okay. Let's move on past these loops because we could spend a lot of time on them and it's useful too, but we have other things to talk about. So we did loops. Loops were important. We did functions. Here they are. If you recall.
Yeah.
What does this function here do?
This function adds x and y.
Correct. So the way to say it is this function adds x to y and returns the result. Yeah?
To y, yes. And returns the result.
Mm-hmm. And how about this one here?
This constant multiplies x to y.
Yeah, this is a funny looking thing. So this is what we call an arrow function because we generate, this is a function here that multiplies x and y. And then this arrow function, we then reassigned it to the constant called multiply, which will multiply x and y. Okay. and we've seen this a couple times when we were doing some stuff, but we'll come back to it. Classes. We did this last time. So
Yes.
I didn't want you to spend too much time learning about classes, and I didn't teach you the terminology to use, but so I will just go over it really fast again. A class is basically something that associates functions and data together. Okay? In this case, the data is, do you want to take a guess? For this class fraction. Yeah, go ahead.
The numerator and the denominator.
Yes. And the method that we have in here is?
Method?
What method have we defined in the fraction class? Method is another word for function, by the way. But we use the word method when it's in a class.
Is it defined though? What the method is?
It's here.
Oh, there. To multiply the numerator of one data set.
One
by
fraction.
Another data set.
Yeah, you can use the word instance is the word we use. So multiply the numerator of one instance with the numerator of another instance.
And the denominator of one instance to a denominator of another instance.
Yeah. Okay, cool. Looks good. And then after that, we did some array processing, if you recall. Things like sorting and filtering and mapping. And last but not least, we did some regex, which I think the homework was to try and replace a bunch of code with some regex. So let's get to the homework. That was a good review. Good job, Satch. I know that's stressful. Put you on the spot like that, and then have all the world see you do it. But good job.
Thank you. It's okay. Only the coders will judge me. Everyone else will be like, she's a genius.
She's a genius, a goddamn genius. Okay, so where do we go? Where do we do you want to do problems? Is this where we were doing problems together?
So the homework we were working on was the anagram thing.
Anagram?
Yeah, the longest anagram with your left hand in the dictionary.
There's no way that I asked you to do that.
Excuse me?
No, we worked so hard on it.
Okay, well, let me just say one thing. You told us to do two things, which was the regex replacement and the anagram thing.
The anagram the anagram that I asked you to do was find two. Hold on, let me find it. I have the original questions in.
Find two words in the dictionary that are the longest anagram.
With your left hand.
Left.
Wait, did I just make up this homework?
No, I gave you a very hard problem to solve, which was to find the longest, not the longest left hand, but the longest pair of words in the dictionary that are anagrams.
Oh no!
Well, do we have a treat for you?
Oh my God.
Why would I care if it's a left-handed anagram? It's more interesting. Don't you want to know what is the answer to the question? What is the longest anagram in the dictionary? That's the real interesting question. Who on earth cares about who cares about whether it's left? You can write it with your left hand. Oh, by the way, the left hand problem came from Dev a long time ago. Did you know? Yeah.
No.
Yeah. He asked me once. He once said to me when he was visiting me in Champaign, he said, Dun, did you know the longest word you can type with your left hand is whatever? I was like, no, I didn't know that. And then I felt like I had to demonstrate it, so I wrote some program to do it. And by the way, back in it ended up being true that the word that he thought it was the longest left-hand word was in fact one of the longest left-hand words. This was before the dictionary I used here, though, where this one here contains like weird like chemistry things in it. So there are some words that are not, that are, I don't know. I would like to limit the set of words in this dictionary to just regular English words, not chemistry words or medicine words. But yeah, he was right.
That's unfair at a certain point.
Yeah.
Just bring
Or
chem
pop
in.
culture words.
Yeah.
Supercalifragilisticexpialidocious.
That's chemistry, isn't it?
Might as well be.
Okay.
Mary Poppins.
So I'm gonna leave you with this homework, by the way, and we'll go over it again next time. I don't want to. Let's see what you did achieve. Let me help you get unstuck.
Okay.
But
I don't know why I thought it was a left-hand thing.
Okay. This is our treat.
This is what happens when I'm involved in recording all of them.
Oh wait, I have to use everything else. Hold on, give me a second.
I also wanted to spend a bit of time on regexes because we didn't spend enough time last time.
It's not even written left-hand on my homework. Sorry.
Vince really wants to know what the longest left-hand anagram is. So I'll tell you what. For the homework, you do both, okay?
Oh no! Well, we're kind of.
Okay, well, I will need just a bit of a lead in terms of based on what we wrote so far.
Yeah, okay. Let's create a new file. New file. Let's call it longest anagram. What's that?
I inputted what we have so far.
Sorry?
I inputted what we have so far, and I don't know if I added it, if it shows up here.
Where did you put it?
I put it in...
Anagram?
Oh no, actually, I don't see it here. Well, I made a new file within our live share.
Oh, what's it called? It's not...
Well, now it's called user bin env node.
Okay,
I
that...
don't think it has a name yet. I just made a new file.
It doesn't. It's not showing up. I'm gonna create it. I'm gonna create it, and you can paste into it. Let's call it longest anagram. .js. Okay. Go ahead and paste what you have there.
And under longest.
All right. Left-hand letters. I see. Okay. Got it. So we've got is left-hand word. Good stuff. That's useful. And we have our anagram signature. Let's reformat the file. Okay. Anagram signature. It's beautiful. And then we have... Oh, by the way, I think I told you folks last time that that the word is anagram signature. I was thinking about it afterwards. I think the better word is fingerprint instead of signature. Well, if a signature works too, but fingerprint. Anyway, doesn't matter. Neither here nor there. So is anagram, okay.
They're both the same thing, though.
Oh, look at this code. Function, longest word. Left-hand words. Let longest left-hand handogram. Left-handogram. Love it.
That's how Rick goes. You're so funny.
I was like, how can I make this variable sound cool?
Left-handogram. Okay. And then you started out by setting it empty. Okay, let's see what we got. Longest word for let word in words if it's a left-hand word. This is fun. Beginner people, this is what you do. It's fun. I like it. No, it's the right way to think. I'm on board. But just so you know, this is redundant. You don't need to say equals true. If it's a left-hand word, equals equals true is redundant because true equals true is always true. And if it's false, you don't need to check if it's equal to true because it's false.
Okay.
But this is good. This means you're thinking. This means you're starting to think the logic through correctly. So I'm happy. I'm not sad. It's just funny because I forget that I even used to do that when I was a kid. Like this is what I would do. I started coding at a young age. You know that. So.
Yeah. What age exactly, though? I need to know.
I think I wrote my first program in grade 4.
No.
What? How
I
did you even do it?
yeah, Dad used to have a he used to have a what's it called? TRS-80 pocket computer, and I used to write. Let me show it to you. TRS-80 pocket computer images. He used to have one of these things. Do you not remember this? Did Dad had this computer here?
Hold on. I'm just waiting for the stream to catch. Oh.
Do you remember this thing?
I do not.
Yeah, it's a computer, and you used to be able to write BASIC in it. Yeah.
I probably thought it was a calculator. Actually, I do remember this.
You do?
I definitely didn't know that was for coding.
Well, I mean,
Slash.
you could write BASIC on it, like a version of BASIC anyway. It was good stuff. Anyway.
Wow, really cool.
Yeah, it was fun times. And then I discovered that language, BASIC, I didn't know that was a common standard language back in the day, but you could write BASIC on that little computer. And then I found out that there's a program there used to be a program on DOS called QBasic. So you could run QBasic, write the same kind of code that would work on that little pocket computer and run it on your computer. That's how I got started way back in the day.
Wow, that's so cool. Meanwhile, we're using calculators to write boobs on it.
In like grade 12.
We created the mathematical formula to get boobless.
Yeah.
Man. So Don, how did you know? Did it come with instructions or something?
Yeah. It came with a book, and you could type these programs out from the book, and then type run, and then play games. I mean, like really, really rudimentary games, but games. Like you could play Hangman. You would type this game out by hand. Like, so you wouldn't get to play the game, right? You sit there and write the game out by hand in the programming language, then run it on the little computer, and you get to play it. And that got you interested. That's what got me interested. From there, it was just like what would like you would make mistakes invariably. You would type something slightly wrong, and then nothing would work. And then you would be like, how do I fix it? And then you have to scroll through on that tiny, tiny one-line display to find the one line you typed incorrectly, sometimes scrolling over to the right beyond the edge of the screen. Oh man, what a pain. I'm so glad we have better computers now.
That's
But
something that you enjoyed it from such a young age, though.
yeah,
It's like you knew your passion from when you were just a baby.
I guess.
That's incredible.
Okay, let's get back to the story. We wanna make some handograms. Handograms, so great. Handograms, left handograms. But no, you can drop the left hand condition. So let's see how you did this. For word and words, and then it looks like you're basically okay. So so this is a filter, right? You're filtering all words for left hand words. Yes?
Right.
Okay.
Yeah, and I'm creating actually a separate array to hold all the left-hand words.
Yes. That's actually a really good way to do this. That's a good way to break down the problem. A problem I didn't ask you to do, but a problem nonetheless. Good job. Next. So now you're Yeah, sounds good. So next, what are you doing? You're looping through each. So you've created an iterate. By the way, you could have done the same thing here, right? You could have said let word in left-hand words. That would have. You could have said for let word of left-hand words as well, unless you need the.
Actually, Thatch's idea was the reason why I didn't do that was because we needed to search between each between the first left-hand word to the second one, and then compare it to the rest of the other. They have the two counters, two independent counters.
You're absolutely correct. Yeah, you're right. My suggestion would not work. Good point. All right, so let's see what you did. Okay, so you said, is this an anagram? So is the current, so let's say that I is the current word. Is the current word an anagram with the next word? Equals true. Good stuff. And then if so this is checking to see if the current word and the word after it are anagrams. And if they are, then you're doing this. So that's a little bit of a mistake, yeah? Because independent, like...
Yeah, it is. I meant to... I think the if...
Okay.
I'm still thinking through it. Very happy with that speak. Okay,
so,
go on.
Should I help you fix it? You're so close. I don't think there's any reason to say go ahead and do this homework again. No, you're doing so well. Okay, for J... This is great. This is an excellent way to do this. Okay, I mean, it's slow. This is a very slow implementation, but it's good. It's a brute force implementation that will work, and I'm on board. Hundo P, as Mitt would say. Hundo P. Is that what you say, Satch?
Sure.
Oh,
I
no.
used to say it until Mitt started saying it. Now I don't say it anymore.
Also, Satch is the origins.
No, I'm just kidding.
Take the Satch. Take the etymology with him.
Okay, I see what you're doing here. So if... Yeah, wait, I don't understand what you're trying to do here. So if the length of this is greater than the length of that...
Sorry, there's some parts of it that I haven't changed yet. So this should be there. And this should be... Oops. Big window piece of pop.
It's like defining, it's like showing you what it means.
Yeah, okay. Yeah. So I think we can safely get rid of this stuff. Let's you're very close. Left. I see what you're trying to do. So you tried to store the various handagrams, that is, into this array, yeah? Okay. So you tried to store them into this array. But what you intended is really to just keep track of the left and the right, yeah? In a sense. Not we're confusing the words left and right, but the idea is when you have an anagram, there's a pair of them, right?
Right.
Okay. But one thing that you may want to consider is that you could have 3 words that are anagrams of each other, or 4 words, right? I mean, they don't ultimately matter, but storing them as a pair, really, you boil it down to just one thing, which is that there is one fingerprint that is the longest. Does that make sense?
Right.
Okay, but don't worry about it. Let's just do it this way. So first thing to do is to check to see if the ith word is an anagram of the jth word. That's how we speak. I take it for granted, but that's how we speak, right?
It makes sense.
So what you want to say here is if is anagram. You need these in parens because this is not Python. And you want to know if the left-hand word at the ith position is an anagram with the left-hand word at the jth position, right? And if they are, you want to do something. I don't want to solve it for you. I think that's the little hint you just needed. You can get rid of this crap. Now you just need to figure this bit out, yeah? So
so yeah, and then at this point it would be, wouldn't this also still come into play? Left-hand words.
I'm not understanding what you're asking. Okay. I see.
Oh yeah, but then I guess.
I see what you're trying to do. Sorry, I misunderstood what you're trying to do. Okay, got it. Let's do that. So what you mean is this. You mean longest left handogram is equal to the left-hand word at I, and you actually mean this to be a 0. And you mean this. Okay, I'm understanding where you're going now. Okay, so this is what you mean, yeah?
Yeah, that's right.
So assign this, but this is not quite correct yet, right?
Oh, right, because we need to compare the length.
Correct.
Oh, right, so that's another one. If. Oh, yeah, that if. I guess.
So they're guaranteed at this point they're guaranteed to be the same length, right? The ith and the jth, if they're anagrams, must also be the same length, right?
Oh, right, but we're also now comparing it to the left-handogram.
Correct.
Longest. Oops. Left. And, yeah.
Nope.
Yeah.
Almost. That's a 0.
Okay.
Because you're only like, if I'm understanding what you're doing, you're just storing the longest one, right? You're never going to store others, right? So you're always checking the 0th. Okay, this is great. This looks good. So a couple of little minor things. I'm just going to be a smart compiler and fix them for you. So you want the length of this word, and you want to compare it with the length of this word. Yeah?
Yes, that's right.
Okay. Let's save it. All right. I think, Vince, you're gonna get your wish today, because
make sure you get rid of this thing, otherwise it's gonna keep printing things.
Oh, thank you. This reminds me of actually programming with Vince. We've programmed together in a live session before, and he'll come in and fix things right before I do things that would break. Okay, so here.
Wait, let me save you 5 minutes of time.
Yeah, and your computer.
Okay, so there it went, and it almost worked. It printed undefined, and that's because you never actually returned anything. And the reason why is because you defined these as variables outside. So I'm going to fix it for you, yeah? Do you mind if I fix it for you?
Would they go right inside?
Yes. Yeah. You would put them in here, first of all, and then at the end, you want to return it. Return the longest left-handogram. Okay? Let's run it again. It's a little bit slow, but it's running, chugging along. Oh, gadgeteers and segregated. Vince.
Oh,
Nice. Oh my god.
Good job.
Oh my gosh.
That's such a nice word. Gadgeteers.
Years segregated. Holy crap.
I hope, Vince, you're still on the stream to have seen it. That was quite great. That was great.
I'm glad I messed up on the taking down the homework notes.
That's fine. I mean, the cool thing is, like, at this point, I think I know what I want you to do for your homework next, because this was interesting. I forced you to do, like, you hard coded to a pair. Supposing now, though, I want you to find me the set of words the set of the largest set of anagrams in the dictionary. Does that make sense? So like imagine that there's a bunch of words, which it would be which set of letters or which word has the most additional other anagrams.
Okay. I think I have a plan.
And while we're at it, left-hand words. But I mean, like, as you can tell, right? I mean, it didn't change the solution by much because of the way you broke the problem down. Does that make sense?
I have a feeling it'll be like a 3-letter word or something like that.
I agree. It's probably going to be a 3-letter word. So that's a good reason to keep it a left-hand word.
Oh, wait, are we really doing that?
Yeah. Oh no, you don't have to do it. No, of course not. You do what you want. I'm happy to grade whatever. Like, you folks learned a lot by doing it this way. You needed a bit of my help, but you did a really great job. I don't care what problem you solve. I'm just happy that you try to solve a problem. So the next, the biggest, actually, the hardest thing about teaching is coming up with good, interesting problems. If you come up with your own, I'm super happy, stoked. Save me a trip to the store, you know? Okay.
Cool. Awesome.
So the reason why I want to ask you this harder version of I think that this next one is a harder version of the question, because the way that you implemented this was a double for loop, right? And the double for loop allowed you to essentially check every possible pair of words. But if the question now is find the largest set of anagrams in the dictionary, you can't do that with a double for loop anymore. You need a new strategy. And the reason I wanted to give you this particular problem is because this is not a syntax problem. This is a thinking problem. How do we go about essentially generating the set of possible anagrams, right? So there's two parts to this. One is think about it, right? And then and like come up with what you think is a valid solution to this. Feel free to use the internet. The internet will always be there. So if you have, like, I think it's interesting to think about the problem, but I won't judge you for looking up the answer on the internet. Go and do what you need to do. And then we can also work on the syntax. But we did a review today, right? And we did this homework, this bit of homework, so that was a lot of fun. We want to go back to some projects soon, right? I'm guessing? Yeah. Satch, you seemed especially interested in maybe looking at some old code that we did together. Let me see if there's a lot of stuff to talk about. So I kind of want to show. Let me see. Let's go into my workspace. And I haven't tried to launch your what was our app called again? Oh yeah, Livre Journal. I haven't tried to launch this since I reinstalled my computer. Good chance it doesn't work. But
so are you working on your MacBook now?
Yeah, I've already sent my old one back to Apple. So get a rebate on the old machine.
Yeah. Oh my God, are you gonna get like 2 more 4K monitors just to test out the HDMI?
No, I'm a minimalist. I like having the fewest number of things. The real reason for wanting the new computer, aside from just being a tech nerd, is I really wanted no fans to run when I'm on stream. I want it to be like just absolutely silent, and it is. It makes me super happy. Yeah. So, do you want to? I have a bit of time. Like, let's spend another. I just want to spend 5 to 10 minutes looking through code we've written before. as a final wrap up so that you can see how much you've learned, right? I think that that's a really nice way to, you know, do you wanna just a little bit?
Yeah. Let's do it.
Okay, so I'm gonna share. Let's live share this with you. This is a different session. I'm gonna paste it here for you.
That's not shared.
Yeah, because we're in a different file now.
Yeah.
But what about these? Are these mine? Or are these ours?
Oh, I think that's.
Did you manage to grab everything you needed, by the way, from the old from here?
Yeah, I'm just grabbing the main.
Yeah, I grabbed it.
You grabbed it? Okay. I'm gonna close it, yeah? Or I can leave it open.
Yeah.
Let me know when you join. Or when you join the new stream.
Yeah, how do I create a new file on my own?
Open a new window.
New window. Oh.
So what was the answer again? Segregated, right? And what?
Yeah, and grab it here.
Get a tier. Yeah. Tiers, plural.
Yeah, so cool. The longest left hand anagram. Segregated. And that's so awesome. Yeah. All right. So so are you in Satch?
Did you send a new link?
It's in the I dropped it in our Discord. Okay. Yeah. So I'm gonna. What I want to do is here's what I'm thinking. Oh, 2 people joined. Yeah. Are you in Satch?
Oh, sorry. That's. I joined in twice.
Oh.
But that was right when I was joining.
Darkmon. You don't need to join. I don't need you to edit any code. You can look at the stream. It's up on the.
It's better live.
Oh, there you are, Satch. Okay.
Okay.
All right. Let's go through. Let's go through some of the things. I know that this code, I imagine to you, doesn't look anything like what you've learned. But it is very similar, and there are some things that are totally different, and there are some things that are JavaScript. I'm going to help you understand both. I think that what might be nice is, in addition to the problem that I assigned you, maybe you could review the code for next time, read through all the files, try to understand things, and I'll sort of test you again next week on stream what various bits of code do, and you can be more prepared. So I'm going to show you how to do it on login, okay? So here we have a bunch of import statements. And if you recall, those import statements are very similar. They're just like the require. Remember when we did require fs to load the file system?
Right.
They're just like that. But for whatever reason, here we use imports. Over there we use require. Long story short, here we would use import. And you don't need to know why. It's not important. There is something under the hood that essentially is doing import instead, okay? How about this line 7? So this is funny looking. It really is very funny looking. And if you've never seen anything like this, you should start by like breaking it down. So remember these curly braces? These curly braces is how we define an object, where we map like a phone book, name to a phone number, right? text transform to none. Make sense? And then notice also that there is a bigger one at the top, right? This one here, starting from line 7, ending on line 17. We have curly braces again. And that's because your phone book can contain additional phone books, right? So the top level phone book has container and button. And those, container and button, instead of just being a phone number, is a phone book inside of it. So the container has its own phone book. And I'm going to stop using the word phone book now. They're called objects, right? So we have the top level object, and then we have a container object, and the container object contains an object. And then that object has min height, which is equal to this, display, which is equal to this, justify content, which is this, so on and so forth. You with me? All right. Then we have this next section here. What is this Satch, line 19? So aside from these extra words, what does it look like?
A function?
That's right. It's a function. It's a function called login. And whenever you have a function, you'll typically see a return statement. So there is a return statement here. So this function is defined. It's called login, and it returns this. Okay? And then how would you read line 20?
It's a constant. Oops. Called auth. Defined as use auth.
And what is this use? What is it? What are these? Do you understand the parentheses at the end of the use auth?
Is that a place where you would put something in there?
Well, I mean, so this is a function call, right? We've done this before. Like when you call a method, we've been console logging most of the time. You call something, and then it returns a value, and then you console log it. But you don't have to log it. You can also just assign it to a variable. So this useAuth is a function, and we called it. And then the result of it is now called auth. And how about this useStyles?
So that's a constant of classes defined as useStyles.
And useStyles is a...
You just said it. I'm only thinking of method though.
Function.
Is it function?
You can with me, you can just say function, method, doesn't matter. There is a difference, but the distinction is not important for now. We'll as we get more comfortable with things, you'll understand the difference. But for the purposes of now, we're mostly ever going to be looking at functions. Methods only show up when you do something like something dot something else, or a function inside of a class, right? But the interesting thing here is, so here we've basically defined a couple constants that are calling some functions and returning some values. Here is an example of that arrow function that we talked about before, right? If you recall arrow functions, yeah? And then this bit down, here, lines 27 onwards, they don't look like any kind of JavaScript at all. That's because they're not. So this part here is stuff we didn't learn in our little crash course. And it's not strictly part of JavaScript. Normal JavaScript you can't do this in normal JavaScript. We'll talk more about that next time though. So oftentimes you'll see things in our code that we've written together with React, and it contains these little bits of things that look like HTML, which is something we should probably talk about, but we'll talk about it also next time. For most of this stuff, if you see these things that look like HTML, just ignore them. They're not part of the JavaScript. The JavaScript is these bits around it. Yeah? Okay. So that's it for today. I've given you everything you need to be able to like read through the JavaScript in other files, like what these import statements are, what all of these different lines do. No, I lied. A lot of these things you won't be able to figure out. Here's a bit of thing that looks like that HTML again. But I mean, just read through it, see how much makes a little bit more sense to you than last time, and then we'll talk more about it next time. Oh, okay. So I think we can end the stream here. I wanted to do some scheduling, but we don't need to do the scheduling on stream. So bye, internets. It was nice seeing ya.
Later.